Okay, hey guys. So, last time I got together with you guys at like different times, and it didn't really work out because like there were just so many people, and I don't really have a lot of time for that. But I am going to try to just explain it using a video, and hopefully that will work for you guys. So, why don't we go to do homework? The nice thing about tonight's homework, or not tonight's, but this week's homework, is that it's like all the same thing. So you're not gonna have to worry too much about not really understanding everything, because once you figure it out, it's like all it is. So in the first one, we have a whole bunch of stuff. But basically, the first question is make a point estimate of the population mean difference in self-esteem between male and female adolescents. Cool thing about this is it's the first mean minus the second mean, so M1 minus M2. And in the equation, M1, I'm just going to say is the higher number. It's also the first number, so M equals 3.9, or no, 39. So you take 39 and subtract it from the second mean, which is 35, and that's your estimate. Little bit down the road, they're going to give you like an MD. It's the same thing as those two means minus the minus each other. So anyway, after you have your estimate, you are going to want to calculate the confidence interval. So to calculate confidence intervals, you have basically 100% would be the entire little graph thing that they have there, but they want 95%. So you want 95% in the body. And I just sent him an email to see how you tell which tests to use, but the majority of these I'm pretty sure are two-tailed tests, so I've just been using two-tailed tests. So once you click on the two-tailed test thing, you're going to want to adjust your degrees of freedom to n minus 2, or, well, n minus 1 plus n minus 1 in this case, since we have two n's that both equal 10, so your degrees of freedom will equal those two 10s minus 2. 10 plus 10 minus 2. And that's your degrees of freedom. So then you just, right. 95% confidence interval means that there's 95% blue, basically. So to calculate that, on my calculator, or on any calculator, you can just do like 100 times point whatever to figure out how much that is. So basically you'd want to multiply 100 by point something to equal 5, because that would be 5%. So I'm just going to tell you that it's 0.05, because 0.05 times 100 is 5, which means that everything beyond 0.05 is the rest of like the other 95%. If that doesn't make sense, like, I'm sorry. It's just whatever. It's 0.05. So what you do is you move the little thingies so that you get 0.025 in each one. 0.025 on the little graph thingy. The little things on the side, 0.025, because you have to have both of these add up to the alpha, and your alpha is 0.05. So then you'd write that in. Oh, yay, goody. Okay, and then you need to calculate pooled variance. They give you sum of squares. So pooled variance is sum of squares plus sum of squares over the 2 degrees of freedom, or in this case just the degrees of freedom you put into the table. So if you need that written out, because I know that sometimes I explain the equations and like people don't always remember, or like can't just conceptualize it. So here's the equation. I don't know. It's like, there you go. Okay. So once you do that, you go ahead and just calculate your pooled variance. Write that in there. And then they want estimated standard error, which is the bottom half of the t equation. And And the t equation you're using for this one, because it's an independent measure test, which means that you're comparing two different samples, two different groups of people, you would have t equals the m1 minus m2 over the square root of pooled variance over n1 plus pooled variance over n2. So that would look like that. Let's calculate the t-score. I should have just written out the bottom half. So when you're looking for standard error, you would just use the bottom half. Yay! Don't even worry about the top half, because the top half you've already done. So once you calculate that using the pooled variance you already found, then you multiply your standard error and your t critical point to find that plus or minus TSMD. Okay, so once you have that, then they want you to calculate confidence interval. So confidence interval for independent measure tests, like the one we're using, use m1 minus m2 plus or minus TSMD. So this, that bottom one right there, that's important to know. That's basically how you calculate the standard or the confidence interval. So what the plus or minus means is that once you find that value for TSMD, you add it to your estimation and you subtract it. So when it says those two boxes like blank to blank, the first one is your mean difference minus TSMD, and the second one is your mean difference plus TSMD. So hopefully that'll make sense. You should have the smaller number in the left box and the bigger number in the right box. And then it wants to ask you whether or not it's significant. I wasn't totally sure on this. I also sent him an email about this, but because we're just our estimate is 3.6. 3.6 is the estimated difference. So I was thinking that means, yeah, it's significant. You really wouldn't be calculating this confidence interval if it wasn't significant. I don't know. I said it was, and that there's a significant difference. I'm not exactly sure about that. Once he emails me back, I'll send out a message regarding that. Otherwise, just guess away, I guess. So that was the first problem. Fairly simple. The second one is the same thing. You calculate the mean difference, so m1 minus m2. This time it wants a 90% confidence interval, so in this case it would be 0.1, because 0.1 times 100 is 10, so that would account for the 10%. So then you'd have a 90% confidence interval, like that. Yep. I did a two-tailed test on this one, because the reason I'm using two-tailed tests on this is because when you read the question, it just says that there's a difference. Like, it's not saying it's increasing or decreasing anything. I was thinking that increasing and decreasing would tell you which tail, like which kind of test, like one-tailed or two-tailed. I don't really know, so I mostly did two-tailed tests on this. And again, I will let you know exactly what we're supposed to do once Mr. Koch responds to my email. Anyway, I used a two-tailed test, and so I adjusted my degrees of freedom to n-1 plus n-1, which, if you'll notice, the n's are different this time, so n1 and m2 are going to actually mean something. So you adjust your degrees of freedom, you move your little slider thingies so that they have 0.05 in each section, and then you take the point at the little yellow number at the bottom, which hopefully you've been doing this enough that you'll remember that, and if not, that's fine. These little tables are pretty handy, but sometimes they're confusing. So that is your critical point that you'll write in the plus or minus for the t, because in this case, the only t-score they want is your t critical.